Continuing on with our Algebra 2 review, we're going to look at nonlinear inequalities, which will move into rational inequalities. So, if you remember, when you did inequalities in algebra, the previous algebra courses that you took, very often you graph these things, and you graphed your parabola, say that's y is equal to x squared minus 1 or something. Then you graphed the other component line, say x plus 1. And you determined if you're looking for all the values that are less than this line, greater than this line, so on. But we're going to take a look at this in a more algorithm or algebraic way. We're not going to necessarily graph them. That is one technique. Another technique is I'm going to walk this through, and you've probably done this before, hopefully you've done this before, is rearrange the inequality. So if you have like an x squared on something and a linear on the right side, get all your x's and everything to one side and set it greater than or less than to 0, whatever the case may be. Then you're going to find those critical numbers. You're basically going to factor and find the zeros. You're going to mark those critical numbers on your number line because we're just looking for the x values right here. That's how we're going to do. So we're just looking at these values, maybe this one and this one or something along those lines. And then you're going to test interviews to see if you have positives or negatives. Actually, it's just going to be these two guys right here if we're looking for less than 0, whatever. Okay. And then we're going to write it in interval or set or inequality notation. All right, so let's go ahead and take a look at a couple examples. So the first one is nothing too innocuous. What we got here, x squared minus x minus 6, easily factorable problem. We've already got it set up. We have our 0 on this side and everything else on the other side. So the first thing I want to do is just go ahead and factor. It's an easy one to factor. And that gives us our critical points. So we're going to have x is equal to 3 and x is equal to a negative 2. I'm going to go ahead and graph those. So here's my 3 and here's my negative 2. I don't care if you used open or closed circles, but I'm using open because that is non-inclusive. All right. So the next thing we're going to do is, well, we got these points down. I'm going to go ahead and come up with some test points. Typically, I would use something like, okay, I'm just going to move 1 over from the negative 2. You don't want to use these points. You want to use something in this range, and in this range, and find out whether you have a positive or a negative. So if I were to do like f of negative 3, all right, and plug this in, I'll plug it in the original one, 9 plus 3 minus 6. I'm going to have a positive right here, all right? And if I were to do like f of 0, and if I get a choice to use 0, I'm going to tend to use 0. 0, 0, negative 6, I'm going to get a negative right here. And I'm going to pick something over here. I could pick 4, 5, 7, it doesn't matter. If I put 4 in here, 16 minus 4 minus 6, looks like it's going to be positive, all right? So I have my positives here, negative and positive. So my solution, being that we're looking for less than, is going to be this right here between negative 2 and 3, non-inclusive because that's not an equal sign. So that's all we're going to do, negative 2, 3. There's my solution. Second one that requires a little bit more effort. So here I have a cubic. So the first thing we would do is, yep, we got it. We got everything to one side. And now I'm just going to have to solve. Now I can start using the techniques that I taught you before, the methods. I can find all my factors, 3 and that's a 1, so I have plus or minus 3, plus or minus 1 basically. So I have 4 possible factors, real factors that I may have on this cubic. Well, to make life easy, you already know which one it's going to be. So I'm going to go ahead and do synthetic division, and I'm going to have 1, negative 3, negative 1, and 3. Drop the 1. 1 times 1 is 1. That gives me a negative 2. 1 times negative 2 gives me that. Gives me this. 1 times negative 3 gives me a negative 3, and I have a 0. And that is a 0. Now keep in mind, when we give you your tests and their time to basically the class period, we factor in the part. We consider that, okay, you may have picked 3 first, or you may have picked negative 1 first, and your synthetic division is what it came up with a remainder. Or they may not have. You may have found the other ones, okay? So it works out that we gave you a nice easy one. So if this was on the test, I can assure you that it would have worked out pretty well, because look at this. So we know we have x is equal to 1. So x minus 1 is one of our factors. And that leaves us with x squared minus 2x minus 3. Another easily factorable 1. We've done this a few times already. So this is nothing more than x minus 1. Of course, we're greater than 0 here. And this is going to be x minus 3. Bigger number gets the sign, that negative right there. And that's going to be x plus 1. All right. So if you used any one of these 3 out of the 4, you would have came up with your solution pretty fast. Alrighty, so next thing, we're going to go ahead and plot all our critical points of x is equal to 1, x is equal to negative 3, and x is equal to negative 1. So here we go. There's negative 1, there's 3, and there is 1. All right. So I'm going to have to test over here, 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 and there. All right. So I got a little bit more testing to do. So let's go ahead and get started. I'm going to pick a number well south of negative 1 here. I could put negative 2, negative 5. And when I put that in, and let's say I get negative 5, that's negative 125. Even if that's going to be a big negative, those are going to be a minor positive and a minor positive. So up here is going to be negative. So this will be a negative right here. Okay? Well, that took care of this interval. I'm going to look at this one. Well, 0 is my favorite thing to work with, so I'm going to put 0, 0, 0, and a positive. All right. Put a little plus sign there to keep me straight. Then I am back to putting in, well, I'm going to put in 2. I mean, I could put in 2.1, 2 point whatever, but I'm doing mental math here. 8, and it looks like we're going to have a bit of a problem here. So that's going to be 4 negative, and that's going to be a bigger negative. It looks like we're going negative right here. Okay. Put in a big number here. 5 is easy to work with. 125. That's going to be, it's going to be 75, but it's not going to overcome the 125. All right, so we're going to be positive on this end. So I'll put a little plus sign right over here. So right here, since we're greater than, these are going to be my solutions. From here, to here, and from here onward. Those are going to be my solutions. So I'm going to go ahead and write it in interval notation. Negative 1, 1, union 3 to infinity and beyond. Alrighty, so that is it, and I will go ahead and get part 2 posted shortly, which we're going to do with rational expressions. So that can get a little bit more interesting, but it's basically the same concept.